Hi, good afternoon to all of you once again on day 2 of the class of AI. I extend a warm welcome to all my participants and also to Dr. Umesh Datta, who has taken out time on a Sunday, and he's actually much required at his home, but he has kind of taken out time to be with us. So I will not take much of your time. I'll simply hand over to Dr. Umesh Datta. But before I do that, there is certain there are certain queries that you had yesterday which I would want to address. So one thing was that about the certificates, you will get the certificates. As I have mentioned in the email, it will take around 3 weeks for you to get them. Number one. Number two, we have very strict cyber policies. And I would want you all to adhere to them. You must understand that any kind of obscene language, any kind of inappropriate language will not be tolerated, and you would be reported to the cyber cell in case we find any such lapses. So please be good people. Good people have come out here to take up time and teach you something new, learn the skill. And I wish you all the very best for today's session. Do not spam the chat. We are here to address every question, and we are taking care of every question that is being asked here. So with that note, I would invite Dr. Umesh Datta now and hand over the stage to him.
Thanks, Anamika, for the introduction and setting up for the day. As we have discussed yesterday, it was all about AI, and today we're going to talk about something called as Arduino.
Your voice is echoing.
Yeah. So I'm joining in from one more device so that I can share my screen. Just allow me a moment.
Right. And we all hope that you all could practice something, could take away something, and you could figure out and read more about what you learned. Is it my voice echoing or your voice echoing? Yes, so if you have missed your attendance yesterday, never mind. We're going to give you another attendance sheet today. Don't worry about that. Yeah, I heard the echo. Yes. Is this the device you want to use, sir? Right. So now I'm handing over the stage to you. We can't hear you.
Am I audible now?
Yes, but there's an echo again.
Okay, no issues at all. I think now it is fine.
Yeah. So
great.
right.
So a very warm welcome to you all, and thanks a lot for attending the session on day 2. And I promise I won't disappoint you today, and we are going to take on something called as Arduino, and we'll do some live exercises, some hands-on exercises today, so that you can get a good flavor of how we can use a hardware called as Arduino and how we can use it for designing some automation applications. Okay. Yesterday, when we had a chat around AI, what it is, how it is different from machine learning, how it is different from deep learning. We saw how Google Teachable Machines can be used for designing some fantastic AI applications. And now today we have to take one step forward, and we have to understand, when it comes to designing some automation systems, how a small chip, a low cost hardware known as Arduino, can be deployed for such a task, and we can actually control some physical devices with the help of that board. So guys, this is what our target is today, that we have to understand how we can make use of Arduino for controlling some physical devices like a LED, or maybe a sensor connected to a Arduino board for designing light sensor, or maybe a motion sensor application. And later on in the second half of the session, I'm going to cover the concept of designing a speech recognition based application. And that speech recognition based application is going to be designed on a platform called as MIT App Inventor. So again, both of them are open source, which means that you can have a free access to both the tools. MIT App Inventor is a browser-based tool, and you can make use of MIT App Inventor for designing mobile phone applications for Android platform, and you can actually deploy it on your device straight away without any hassle. And in 20 minutes, you can get the app that you are going to design on your own in your device. So it's going to be an exciting thing. Why? Because till now you have been a consumer, you have consumed the applications which have been designed by someone else, and today there's an opportunity where you are going to make use of your own application which you will design. Okay, so we'll do a live demo of that. And yes, get your phones ready, because I will be deploying the applications in your phone rather than deploying it in my phone. Okay, so whatever we are going to design today, uh, you will deploy it on your phone straight away, right away, right? So it's not like I am going to use my phone to deploy it and I will show you the demo. No, not at all like that. It's going to be something which you are going to deploy on your phones, and you are going to design it with me live today. Okay. So this is going to be part 2, and in part 3 we will have a formal Q&A where you can ask me any question related to today's session, and also the session that we had yesterday. We'll answer them. We'll answer all the queries that you may have. Okay, so this is how the flow will be. Starting off with LED, moving on in part 2, I will be discussing about motion sensor, and part 3 will be light dependent sensor, or maybe you can say a light detector circuitry, which you can design using Arduino. Part 4 will be on MIT App Inventor, where we're going to make use of MIT App Inventor for designing a speech recognition based application, speech recognizer. And in the last, at the last, we are going to have a Q&A. In between also we will talk and we will have a Q&A, but formal Q&A will be at the end today. Okay, because there are lots of hands-on exercises involved. I'm sure that there will be a lot of questions, and I'm ready for them. I will be answering them at the last 10 minutes. I'm blocking for that particular activity. So this is how the flow will be for the entire session. And without wasting much time, I'll try to share my screen. Let me know whenever it is visible, and we will kickstart the development straight away. So I'm sharing my screen. Let me know once it is visible, and I need access for admin so that I can share it. I hope it is visible now. I think it is visible. So guys, the first thing you have to do is you have to go to a platform called Tinkercad Circuits. Okay, so this is a platform, Tinkercad Circuits, and you have to make use of your Google account for logging into this particular platform. So you have to just click on sign in, and in case you want to join the platform, you have to click on join now. Okay, so in case you are using the platform for the first time, you can click on join now and create your personal account. Okay, so once you create your personal account, it will ask you whether you want to sign in with Google or sign in with Apple. So in case you have a Gmail account, you can directly use your Gmail account for signing into this particular platform. Okay, so you have an option either to use your Apple account or your Gmail account for signing into this particular platform called Tinkercad Circuits. Okay, so since I have already signed up, so I will not use this join now option. What I will do, I'll make use of this sign in, and I'll say I'm gonna sign in with Google. Okay, so already I am logged into my Google account. So it is going to ask me which particular account I want to use for this application. So let me take into account one of my Gmail accounts, and I'll just authenticate it. So it's a basic authentication, guys, that you need to do. A simple Google account linking with this Tinkercad platform so that you can easily log in. Okay, so once you log into this particular platform, this is how the view will be. We need to click on circuits, and in the circuit panel, you have to click on this option called create a new circuit. Okay. So once you click on this create a new circuit, it is going to create a new schematic for you. It is going to give you a new window where you can design your project. Okay. So here we are going to take into consideration one open source platform, which is Arduino. Okay. Guys, this is one of the most widely used open source physical prototyping platform in the world today, and primarily it is used for prototyping of the electronic circuitry. Okay, so whether you want to design healthcare applications, robotic applications, automation applications, I think this is one platform that you can rely upon for prototyping purpose. Okay, before you design your final product, you do a prototype just to make sure that whatever you're thinking, it is really getting implemented. So prototyping has to be done, and this is one of the easiest way that you can choose for prototyping of your applications that you are designing in any of the domains, whether it is falling under agriculture, it is a healthcare application, it is a robotics application, it is an automation application, or maybe an application which is a combination of various sectors. Okay, or maybe a combination of various fields. So this is one of the most widely used and a go-to platform today all over the world. And in schools, particularly, the kind of impact this particular platform has made in the last 3-4 years, it's truly a remarkable thing. Why? Because of the fact that it's low cost, it's powerful, and at the same time, it allows you to perform some actions related to programming without spending much time on the learning path, which means that the learning path is quite easy, and the platform itself is so user friendly and so easy to learn that it becomes fun when you are using this particular platform for designing your own applications. Okay, so you can see that the heart of this particular board is this one. This is a chip, this is a microcontroller, this is a computer on a chip kind of a device. So you can take it as a chip or IC. We call it as a computer on a chip because it has got its own brain, it has got CPU, and this is going to perform the job for you. And you have to just make sure that you program it, and it has its own programming environment that is called as IDE, Integrated Development Environment. So there are two options, guys. One, we can make use of Arduino IDE, that is the official software of Arduino for programming this particular board. And the other option is that we make use of Tinkercad, which we are currently using right now. You can see on the screen that we are actually on the Tinkercad environment, and we can make use of this particular environment for designing the applications on Arduino. So we are going to make use of this environment only as of now, but you are free to use Arduino IDE. You can already use this particular platform. You can download the software from the official website of Arduino, and you can use it without any hassle. I mean, there is no fees involved in terms of downloading the software, using the software. It's completely open source in terms of both hardware as well as software. That's the beauty of this particular platform. That it's open source in terms of software, open source in terms of hardware. Okay, so that's why the community has grown a lot. Why? Because it's something which is driven by the community. Okay, so that's the power. And let me show you the official website, and that's arduino.cc. This is the official website of Arduino. You can download your Arduino from this particular website. Okay, so you can see this is the one. Okay, nicely documented. You will get a lot of good resources from here, and you have to just click on software. And once you click on software, you will be taken to a new window where you just need to download the software according to the compatibility of your system. So if you're using Windows 7, Windows 8, Linux, or maybe a Mac machine, in that case, you have to just download the software which is compatible to your own machine's specification. That's it, nothing else. Okay, so that's one thing, guys, that you need to do in case you want to use Arduino IDE. That is the integrated development environment for programming the Arduino board. That's what you need to do. In case you are just starting off with the journey of Arduino and you are a beginner, you don't know what exactly it is, guys, for you, the three things that you need to learn and know is that it's open source platform. Okay, number one. Number two, it's open source, both in terms of software and hardware. Number three, it's a platform that we use for prototyping of our application, our electronic circuit applications. Okay, that's what it exactly is. And the heart is the microcontroller that we have over here. This is what is going to perform the job for you. This board can be programmed, and board can be programmed with the help of an integrated development environment. Loosely, we call it as a software, and the software is again free to download, and it is available on this particular website, arduino.cc. And there is a simulator also which is available, that is called as Tinkercad from Autodesk. So we are going to make use of Tinkercad so as to perform the simulations live without having hardware with us. We are in the lockdown phase. Surely soon you will be having these hardwares with you once you get to know the power and the capabilities of this particular hardware. But in case you don't have the hardware right now with you, don't worry, don't panic. This is a simulator which is going to allow us to perform whatever action you want to do, whether it is going to be controlling the LED, controlling something called as the sensor, taking the data from the sensor, and finally performing some action. Everything will be done in this particular simulation environment called Autodesk Tinkercad. Okay, so guys, this is what we are going to use today. And now let's get started with the programming. Okay, so if you are new to the platform, I'll have two suggestions for you. Don't worry at all. This is open source. The learning curve is so smooth, so easy. Don't worry at all. We're not going to run through a presentation. That's a good news. Okay, so we are not going to get bored with the presentation. So you can see that we are going to do something experimentally. So I'll show you how this board looks like. So it has certain pins over here. You can see that the numbers are given 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are the pins which are available over here on this side. On the top side, on the bottom side, we have got A0, A1, A2, A3, A4, A5. So these are the pins which are available on the bottom side. These are analog pins and these are digital pins. Okay. So guys, again, a big thing that you need to understand that in electronics, there are two kind of signals, two kind of quantities, analog and digital. Digital is in the form of 0 and 1, high and low. Analog is something which is continuous in nature. It can take any value. Okay. So if I want to say a digital, it will be either 0 or 1. If I say analog, it can take any value, 2.3, 4.7, 3.24, 3.85, whatever it is. Okay. Apart from that, this board is powered with the help of USB cable. So you can just plug in a USB over here and connect the other end of the USB cable onto the computer or a laptop so that the board can be powered. Okay. Apart from that, there are certain pins which are for power and for ground, so that in case you have any external circuitry like a LED or a push button or any sensor and you want to provide supply to those circuitry, you can take those supply from Arduino board itself. You need not to have an external supply. So you can have the provision of 5 volts from this side, ground is available over here, and on this side also you have a ground. And in case you get stuck somewhere, the controller gets hang and the process is not happening, there is a button over here, this one. This is a push button. You can press this particular push button so that you can have a reset operation which can take place and everything will start from the beginning. Okay. It has got an onboard LED which is connected to pin number 13. You can see this is the LED. So LED is for indication. In a lot of applications, we make use of LED so that we can get to know the status, what is happening in our circuitry. So guys, we can make use of this particular LED for our own convenience whenever we are designing any logic, so that we can get to know whether the logic is performing properly or not, is getting performed properly or not. Okay, so that's how this board looks like. So let us try to connect a LED. So I'll pick up a breadboard. Okay, so what we can do, we can pick up a breadboard. You can see this is a breadboard. So this is the one that we are talking about. Right. Yeah. So a small breadboard on this side, Arduino on this side. So what I'm gonna do, guys, I'll pick up a simple LED, and this is the one. I'll just bring it and I will push it over here on the breadboard. So you can see LED has two terminals. One is anode, the other one is cathode. Cathode is negative, anode is positive. This cathode has to be connected to ground. So I'll connect it to this point minus. So this is now grounded. I can change the wire color from here, and I will use black for ground. So this is what I have done. Next, what I need is the resistance so that I can connect it with my LED, and this resistance has to be connected over here. You can rotate it with the help of R, okay? And you can change the property of this particular resistance also in case you want to change the value of resistance. So I'll just drag it and I will push it over here like this, and I'll change the resistance value to ohm scale, and the value will be, let us say, 330 ohm. So you have to use a small value of resistance in case you are connecting a resistance in series with the LED, okay? So you can just use R key on the keyboard as a shortcut, and you can rotate this particular resistance, and that's how you connect it. So one end of the resistance is connected to anode. The other end of the resistance we are going to connect it to one of the pins of Arduino. So let's connect it to pin number 2. Perfect. And we can make use of blue color for this. Right. So next what we need to do, we need to make sure that the ground of Arduino, which is this one, is connected to the ground of breadboard. So you can actually connect this particular ground, take a wire, bend it like this, take it up, and from here you can take it on the negative side like this. Just tweak it a bit like this. Okay, fine. And if you want to change the color, you can just select it and change it to black. Now you can see what is happening in this particular circuitry, that we have connected the ground of Arduino with the cathode terminal, and the cathode terminal is grounded. LED has anode terminal, which we have connected to a resistance, and then the other end of the resistance is connected to pin number 2, so that we can actually give some signal to the LED. Now, if I want LED to be controlled, I want a blinking operation. LED should blink high, low, high, low, high, low, high, low. So what I need to do, I need to program this particular board so that I can have a high signal on pin number 2, and then after some delay, give a low signal, and then after some delay, again repeat the job. That's what I need to do. So what I will do, guys, I will write a basic code for this particular application so that I can have the blinking operation of the LED. So you just need to click on this button called code and select the text editor so that actually you can have the coding environment. So this is a coding environment, guys. You can just delete this code and we can start writing the code from scratch. Just give me a moment. Just give me a moment. Yeah. So what we can do now is back. Just give me a moment so that I can plug in the supply for my cell phone. Just give me a moment. Yeah. So we can kickstart again, and it's perfectly fine now from my side. I'm sorry for the interruption. So what I've done, I've connected the LED in the circuitry. What I need to do now is to define two functions. So in this particular case, you have two functions that you have to declare in the programming. So one is the setup function, guys, and the other is a loop function, void loop. So these are the two functions that you have to declare in the program. The first thing that we need to do is we need to declare the pin that we are using in our circuitry as the output pin. So you can see guys over here that we are making use of pin number 2, and in this case we have to declare pin number 2 as output. So pin mode is the command, and then we are going to write 2 comma output. So this is going to configure pin number 2 as the output port pin. Next, what we need to do, if we want to blink the LED, guys, the first thing that you need to do is to make sure that you make the state of pin number 2 as high. So you can do that by writing a command called digital write, and then within the bracket you can write 2 comma high. Perfectly fine. And then you have to make sure that you make sure that the LED is in the on state for some time. So it has to be given some delay. You have to give some delay over here. So you give delay, let's give it 1000 so that we can have 1000 milliseconds of delay, which means 1 second of delay. And after that, what you do, you can make use of another digital write and say 2 comma low, so that the LED which was turned on can be turned off. Okay, so now if I write 2 comma low, it is going to turn off the LED, and then again you can give some delay of 1000 so that you can have a 1 second delay again. Okay, so this is what we have done. We have configured pin number 2 as output, and then we have made the state of pin number 2 as high, give some delay, make the state of pin number 2 as low, and then again give some delay. That's it, nothing else. So in this case, what can you expect? You can expect the LED to blink. Why? Because remember what happens in Diwali lights. What happens over there? They do like this: on off, on off, on off, on off. So when you say on off, you make it high first so that LED turns on. Give some delay so that it remains in the on state. Make it low so that it turns off, and make sure again you give some delay so that it remains in the off state for some time. Since this particular program is written in the loop function, so you have to make sure that you write all these commands that I have written in the loop function. If you write it in the loop function in Arduino is a function which repeats itself again and again. So it's sort of an infinite loop. It's a programming function that is going to repeat itself. So it's an infinite loop, guys, that is going to take place. So once the first command is executed, then second, then third, then fourth, and then the process is going to repeat itself again and again. Okay, so that's what happens over here, that in the loop function, whatever you write, it gets executed again and again. Okay, so till the time the controller, the Arduino board is powered, you will have the loop function getting repeated. That's it, nothing else. So guys, you have written your first program. Congratulations on Arduino. Now let us test it. How can we test it? We have to start the simulation. That's it, nothing else. So we have to click on the start simulation button. And once I click on start simulation, what I will do, I'll just close this window. And now you can see, guys, over here. Just put your attention on the LED. What is happening over here? LED is blinking. So you can see that it's blinking every 1 second. It goes to the on state, remains in the on state for some time, goes to the off state, and then comes back after some time. So this process is getting repeated, and you can see that you will have a blinking effect, guys. That's it. So it's working perfectly fine. And congratulations now for designing your first application on Arduino and simulating it on Tinkercad. So you are successfully able to control a simple LED by making use of Arduino, and you have tested the circuitry on a platform called Tinkercad. Okay, so anyway, whenever you are going to design any circuitry for automation application, LED is something which is an indicator, which is going to indicate whether it is functioning fine or not. Okay, so when you go and make use of a stabilizer in your air conditioner, you can see a LED over there. Once you turn on the MCB, you can see LED is turned on. So if LED is turned on, you will say fine, it's working. That's what you do. Similarly, when you go to any other circuitry, if LED is blinking over there or LED is turning on, you can say that it's functioning, power is coming. So somewhere LED is used as an indicator in the circuitry. So you must know how to control a simple LED using a basic electronic circuitry, and this is what we have done. We have programmed this particular board called Arduino, and we are able to successfully create a blinking effect of the onboard LED, guys. Of the LED which we have connected on pin number 2, not the onboard LED, because onboard LED is connected to pin number 13, guys. So if I want to control this onboard LED which is connected to pin number 13, how can I do that, guys? Let's try this one. So I'll stop the simulation. I'll go back to the coding environment, and here I know that my onboard LED is connected to pin number 13, so I'm gonna say pin mode 13 comma output. That's what I will say. And here I'll write one more line, digital write 13 comma low, which is going to make the state of pin number 13 as low. But we have to make it high initially, guys. Why? Because we want to turn it on, and you have to make it low over here. So you can write digital write, and you can write 13 comma low. Right. So that's what you need to do, guys. You have to make it high, and then after some time you have to make it low. That's it. Nothing else. So what you need to do now is to start the simulation and see what happens on pin number 13, guys. So you can see that this is pin number 13. Put your attention over here on this part, and now you can see two LEDs are blinking after every 1 second. The LED which you have connected on pin number 2 is also blinking, and the LED which is there on the board, which is connected to pin number 13, is also blinking every 1 second. Okay, so you have just tweaked the program, and you are able to actually control two LEDs with a simple program. Okay, so I hope you have understood the logic. If you have any questions regarding this, please let me know. Otherwise, I can show you one more approach of block-based coding. So guys, this is the approach that we have for block-based coding. So you can see that here you need not to write a program or a physical instruction. What you need to do is you have to actually make use of something called as a block so that you can actually create the logic that you want to create. Okay, so you can see that here in this case, it's a built-in LED which is made high. After 1 second, it is made low. So what we can do is we can actually take this block also, join it over here, and change it to pin number 2. Because we are using pin number 2, we make pin number 2 as high, and then again drag this block, take it over here, place it here, take pin number 2, and now make it low. That's it. So now you can see that the logic has been designed using a block-based approach. And if I start simulation, again the same thing is going to happen. So you can see both of the LEDs are actually getting controlled, and they're getting controlled with the help of block-based approach. Okay, so you can either code or you can either drag and drop and program as per the logic that you want to design. If I want to change the delay, you can just change this parameter. Instead of 1, I can create 0.3 second delay. I can change it to 0.3, and here also I can change it to 0.3 seconds. So guys, now when I start simulating this particular circuitry, you can see that LED is blinking quite faster. You can see high low is happening quite faster. Okay, so the blinking effect of the LED is happening at a good pace now. Why? Because the delay has been reduced from 1 second to 0.3 seconds. So you can see that LED is blinking quite faster. Okay, approximately 3 times per second it is going to blink. So that's how it is. And now you know that there are two different kind of approaches. If you are a coding audience, if you know how to code, if you want to actually learn how to code on Arduino, you can make use of the coding based approach. And in case you are a student of class 6, class 7, and you are just beginning your journey with Arduino and you don't want to code straight away, this platform allows you to do that. You can actually make use of block-based programming. And block-based programming is something which is similar to Scratch, the one which you do for creating games, storylines, and you just need to drag and drop the blocks and it will do the job for you. Okay. So this is a block-based approach, guys, that I've shown you. So you have two approaches and you have to choose which one you want to follow, because block-based is fine, but at the same time, the kind of liberty and the kind of free hand you have when you program is something which you are not going to get in the block-based programming approach. Why? Because the blocks have a fixed functionality, they have a fixed nature, they have a fixed coding running at the back end. And if you bring in a block into your programming environment and join the blocks in a particular way, you're going to design a logic in a proper way, but at the same time, you can't tweak it much. That's where the problem is. And it's fine. It's something which is a problem which will come later on, because there are a hell lot of blocks that you can make use of and you can get the job done whatever you have in hand. So don't worry about that. Just make sure that you start your learning curve either using a block-based approach or a programming approach. Both of them are easy to follow and easy to follow along. And my suggestion is that if you are just a beginner, you are starting it for the very first time, get your hands dirty on the block-based programming approach first, so that you can actually learn the art of programming via making logics with the help of this block-based programming technique. And once you're done with that, next step would be to learn the programming. That is the programming for Arduino, and it's based on C programming fundamentals. And if you have C programming fundamentals clear, it becomes quite easy. Okay. Otherwise, if you have any programming language fundamentals with you, maybe Python, it is again going to be a helpful resource. Okay. So my suggestion is for kids who are doing it for the first time, do it using block-based approach, and then later on switch to a program-based approach. And those who are in ninth, 10th, 11th, 12th senior classes, you can get started with the coding straight away because you have some sort of a background of coding with you, and that will really help you out in terms of getting started with this particular platform. The learning curve is quite easy. It's not going to be tough for you. There are a lot of resources available on internet that you can make use of, and you can learn the programming without any hassle, without any difficulty, and you will become a pro in no time. Believe me, if you start working on this platform and you start exploring different kind of opportunities that this platform is going to offer you. Okay, so that's it, guys. This is first exercise that I had for you for today, and we have successfully completed it within the time bounds that I have kept. Congratulations. And now if you have any questions for me, please feel free to ask. I will be more than happy to take them on and give my views on them. So Namika, you have to help me out with the questions in case there are any questions coming in the chat box so that I can answer them before we start developing another application, which is a motion sensor based application. Okay, so we're going to do that very soon. But before that, in case you have any question, I'll be more than happy to take them on.
So the question is whether they
Do we
can
have any
use.
questions?
Yes, the question is whether they can use Java or Python for coding.
Not at all. For this platform, it's not going to help you with Java or Python.
What if we don't know how to
But
code?
yes, here you can make use of either block-based approach or Arduino programming. You can make use of that. For Arduino board, for Arduino Uno, specifically the one which I have shown you, you can make use of Arduino programming or block-based programming, no Python and no Java.
There's another question. Just a second. So there's spammers are all around. So can what if we don't know how to code? Will this work?
Yeah, why not? I mean, that's what is required, that you have to answer yourself whether you know how to code or not. Nobody is born a coder. You have to start your learning curve at a particular point of time. That's what it is. I mean, who told you that you have to be a coder to start? You have to just start. If you have a logical thinking, and if you know that you can think logically, I think this platform will be very easy for you to get around. And the learning curve, as I told you, is something which is very user friendly and very easy. So it's learning by doing that you generally learn better. That we always encourage and tell our students also, that when you do and learn with that, I think the learnings will be there with you for a longer time. So that's what you have to try, that whenever you have a learning going on in Arduino or any other platform, you should have a simulator with you so that you can try. You should have a hardware with you so that you can actually implement the things that you design. And little exercises, small exercises, the confidence of success in achieving the goals in small exercises is going to do wonders for you to achieve the big things. So if you want to start learning this particular thing, and if you don't have a coding experience, perfectly fine. Just get onto the platform, use block-based programming, and just join the blocks and do the things. Once you have the logic with you, once you know how to build the application, the logic is clear to you, I think then you can get on with the coding curve and take on the bigger problems, take on the complex problems with the help of Arduino and solve them.
Right. The other question is how many types of Arduinos do we have?
Lot of them. I mean, hell lot of them. I mean, just allow me to open this Arduino IDE also so that I can give you a flavor of that. So this is Arduino IDE, Arduino's official software, Arduino Integrated Development Environment. So if I go to tools and I go to boards, so you can see that these are the boards which can be programmed. So you can see there is Arduino Uno, Arduino Nano, Arduino Mega, Arduino Leonardo, Micro, Explora, Mini, Fio, BT. So you can see that there are a hell lot of boards available in the market from Arduino itself, right? So every board is different in terms of their capability. Every board has a specific functionality, specific feature. So how do you differentiate between these boards? I would say that there are certain boards which are having small size, which are suitable for wearable applications. If you want to design a smartwatch, if you want a gadget which is of small size, in that case, you have small footprint based boards like Arduino Nano, Arduino Mini, which are going to give you the opportunity for programming on Arduino environment, but at the same time, the floor area, the PCB area is going to be very small. So it is going to be quite handy gadget to have in case you want to design any wearable application. But in case you want more GPIO pins, you have at least 50 devices that you want to control with the help of single board. In that case, probably you have to go for Arduino Mega, which allows you to have so many pins with you so that you can actually control 60 devices, 50 devices with that board, single board. And for general purpose, if you are a starter, we always recommend that go for Arduino Uno because it has got 14 digital pins, 6 analog pins. So in total, you get around 20 pins. 0 to 13 indicates digital, A0 to A5 indicates analog. So in total, you have 16, or you have 14 plus 6. In total, you have 20 pins that you can make use of for controlling any application you have. So it's enough for the starters, but at the same time, when you go ahead with bigger application, you have to see which board is going to suit your requirements. In case you have Bluetooth requirement, in case you have Wi-Fi requirement for your application, probably would like to have the Arduino boards which have integrated Wi-Fi or integrated Bluetooth module. And the memory is also another thing that you always keep into consideration, whether the application that you are designing is the Arduino board that you are using is sufficient in terms of memory requirement for your application is another thing that you need to see. So these are certain things that you need to first understand as per your application requirement before you choose any Arduino board for your application. So there are a number of boards available, guys. To start off your journey, start with Arduino Uno. If you want to design something in the wearable category, make use of Nano or a Mini. If you have a big application in hand which is requiring more number of pins, go for something called as Mega. If you want to control the PC's mouse and the keyboard, probably go for something called as Leonardo because it has HID, which allows you to control the PC's mouse and keyboard with the help of Arduino, which other boards probably don't allow you to do. So it all depends upon the application requirement. And once you have the application requirements and specifications clear, then it becomes quite easy to understand and choose the Arduino board for your application.
Perfect. There's a question. Can Windows 7 run this program?
Sorry, coming in?
Can Windows 7 run this program?
Yes, it can. It can. It can easily do that. Windows 7, Windows 8, Windows 10, Mac, a Linux machine. I'm using a Linux machine right now, Ubuntu 18. So it works perfectly fine. Even it works in your mobile phone, guys. So you can download the application from Play Store for Arduino, and you can make use of your mobile phone and start programming on mobile itself. Just connect your Arduino with that mobile phone.
Can we do it on IntelliJ IDEA? IntelliJ IDEA?
Yeah, you can.
Which one is better, Arduino or Raspberry Pi?
Okay, big thanks for this question because this I think is the question of the day so far. So anybody who has asked this question, I don't know who has asked, but a great question. There are a lot of boards available in the market, guys. Right from Arduino to Raspberry Pi to Jetson Nano, there are a number of boards available. BeagleBone is another popular choice. Some fantastic boards are available from Texas Instruments also, MSP430, MSP432, TIVA. There are a number of boards which are there on the floor now, right? So Raspberry Pi is something which is designed for something else, but now we have actually dragged it to somewhere else. Okay, so let me put it in this way. It was actually designed to make sure that the countries which cannot afford computers can get computer at an affordable cost. That was the mindset when it was designed. But since the board was so good in terms of feature, we embedded engineers thought that rather than restricting it to become a computer for a country which cannot afford computers, or maybe people where the economy does not allow people to invest so much in the compute power, they getting the computer. I think people from embedded communities saw the potential and dragged this particular board into the embedded application. So somehow it was reverse engineering which was done, and it got into the embedded market. And believe me, the cost is something which decides everything. If you go and purchase any gadget, the first thing which you ask right now is what is the cost. Yes, quality matters. That's another thing. but cost is something which you always have as one of the parameters. If I am getting something at 20 rupees and for that I have to invest 4,000 rupees, quality is same, everything same, then who is going to pay 4,000 rupees saying that it is a design on Raspberry Pi, it is a design on Arduino? So guys, this is what is important to understand, that the costing at some point of time is going to play a very, very important role. And you have to make sure that the application that you're designing is something which you can provide to your customer at a low cost. In terms of feature, Raspberry Pi allows you to program it in Python. It is actually a computer. It is actually a computer. Why? Because you attach keyboard, mouse, and you have a Wi-Fi. Everything is there. You have OS over there, which is Raspbian. You have SD card with you. Everything is there. It is actually a computer. It is not at all a small chip based embedded board. It is actually a computer. But yes, it is. It is being dragged into that community, and now it is one of the hot shots in embedded community for designing embedded applications. So both of these boards can design these applications, embedded applications, robotic applications.
We lost your voice. We lost your voice. We can't hear you.
A lot. Why? Is because you have. Yeah. So I'm back online.
Yes.
I hope I am audible.
Yes, you're audible now. Right. So there's another question that is going around here is when to use analog and when to use digital.
Give me.
Yeah.
Audible now?
Yes, you are. Right. So when to use analog and when to use digital? That was the question.
Am I audible now?
You are audible. Yes. Yes.
Yeah. So I hope I am audible now. I'm sorry.
Yes, yes, you are audible. Absolutely.
So yeah, we can have the question now.
So analog or digital? When to use what?
Namika, can you repeat the question again?
When do we use analog and when do we use digital?
Okay, again a nice question. Something too technical. Shortly, I will answer it. When do we use analog and when do we use digital? So analog pins generally they are going to be used when you have any sensor which is providing you analog output and you want to process it. So analog to digital converter is available on the chip itself in Arduino Uno. That means the chip that we are using over here is from Atmel, Atmega 328D, and this particular chip has got analog to digital converter which is inbuilt, and the pin out is on A0 to A5. So you can connect the output of the sensor on any of the analog pins, and you can actually process the sensor output and digitize it. So in case you want to perform analog to digital conversion, you make use of these analog pins, And in case you want to just provide the digital output and take the digital input, you make use of digital pins from 0 to 13. But do not take it as an assumption that analog pins cannot handle the digital signals. This is a special functionality that those pins have, that they can handle the analog input. But at the same time, they are equally good to provide digital output and also process digital input. Okay, so this is a special functionality with A0 to A0 to A5 pins, that they can process the analog data. And in case you want to perform analog to digital conversion, you have to make use of A0 to A5. So if you have a temperature sensor or a humidity sensor or a pressure sensor that you are making use of, and you have analog output from the sensor, you can connect it to an A0 to A5, and you can actually perform analog to digital conversion to convert that analog data into digital data for further processing. And this is only possible on A0 to A5, not on 0 to 13. But if you want to just take digital input and you want to provide a digital output, you can make use of any of the pins, either digital or analog. Okay, so this is all the differences.
How much RAM is required to run the application?
Which RAM is?
How much RAM is required to run the application?
Okay, so it's quite basic one. I mean, it's not like it's quite light in terms of its design. It's a lightweight software. You don't need a heavy RAM in your PC. We have tried it on 2 GB system. It works perfectly fine over there. 4 GB again is good. If you want to give a minimum specification, on the official website they will say something, and you can make use of those specifications. But at the same time, if you ask me from my experience, anything which has a 2 GB RAM or a 1 GB RAM will be sufficient to run this particular software. So it's not heavy in terms of its requirements, compute requirements, and it's quite lightweight, and it works very fine with the systems which are of 1 GB or 2 GB RAM. It's sufficient. It's not like a Unity software which needs heavy RAM, and it's something which is quite lightweight. Even on Raspberry Pi, you can use Arduino, which means you can install Raspberry Pi. You can install Arduino on Raspberry Pi and use Raspberry Pi to run Arduino applications by connecting Arduino with Raspberry Pi with one of the USB ports. So that is again a possibility.
For which application is Tinkercad mostly used?
Sorry?
For which application is Tinkercad mostly used?
Tinkercad is mostly used for prototyping, I think, for simulation of circuitry. Why? Because look, when you design anything, one is you should know how to code or how to design application. The next is where you will test the application if you don't have the hardware. So either you purchase the hardware and test directly on the hardware, okay, which is going to cause a bit of investment, not much, but some investment has to be given. Some investment has to be made. But guys, if you want to try your logic, you want to try your skills, we always recommend that first simulate. First be sure on the simulator, because if you do anything wrong, if anything goes wrong, it is going to go wrong on the software, on the simulator. And in case anything goes wrong on the hardware, you may end up killing your circuitry. You may end up burning out your Arduino board. You may cause burnout to any other peripheral that you are using. If you connect one wire here and there, you may cause a loss of money. Why? Because your board which you have purchased will not work later on if you have connected the wires in a wrong way. So you have to be 100% sure how you are connecting your Arduino with the peripherals. And in order to make sure that you are comfortable doing that, my suggestion is always make sure that you simulate first, have a good idea how to connect the wire, hook up the circuitry, and then you go and do the physical connections. So simulator is going to be a handy tool in any of the case scenario that you will take on. So in this case, Tinkercad is one of the free tools that you can use for simulation of Arduino-based circuitry, and it's a handy tool for designing any application that you want on Arduino. It's not a tool which allows you to do everything, but it's a good tool to actually tinker around with the stuff that you design by making use of Arduino. So enough support is available, enough sensors are available. But if you ask me, it is the best one? I won't say that. Why? Because the other tools which are available in the market are even better than this. Why? Because they allow you to have they may allow you to have the Arduino to be used in conjunction with other sensors which are not available in the library of this particular tool called Tinkercad. So there are certain sensors which are not available over here, but that will come later on once you master the art of using the sensors which are already available. So let's talk about what is available, what are the positives of this particular platform. And yes, it's something which is in the evolving phase. The designers of the Tinkercad are putting up their best effort to make sure that they provide you the libraries and the components in the Tinkercad environment so that you can use as much components as you want. But yes, this is something which is progressive. It's gonna take some time to bring in everything that you want. But yes, a lot of things are already available. Just tinker around, just have a good feel and good know-how of programming and hooking up the circuitry. Once you're done with that, you can just go and purchase the hardware and start trying out your logics over there in the hardware directly.
So I'll take one last question now. I'm using Arduino to in a prosthetic hand. Is it good for it?
Why not? Why not? It's something which you can try it out. Why? Because if you're trying to make some prosthetic hand or something like that, ultimately there will be some sort of motors that you are trying to control with the help of Arduino, whether it is a DC or a stepper or a servo. So you can make use of Arduino for controlling those motors and actually test it out. Later on, if you want to move towards the product development phase, once your prototyping is done, yes, you then in that case probably can think of using the chip directly rather than using the entire board, and maybe try to optimize your code from the accuracy point of view, uh, so that certain lapses which are there in those open source libraries, you may not get into those kind of things, and you get what you want in terms of accuracy from the project that you're developing. So for prototyping, it's excellent. You can try it out. Absolutely no issues in that. It allows you to control different kind of motors, whether it is servo, DC, or stepper with good precision, good accuracy. And later on, once you get into the product phase, I would recommend that you use a chip once it is programmed, and then design your custom PCB for the prosthetic hand, so that you get what you want in terms of the product size, in terms of product quality, and in terms of the accuracy in terms of operation.
Perfect. So now we can move to the next part of the session.
Perfect. So we'll get on with another exercise that we have planned for you. So what I will do over here is I'll pick up Arduino again. So this is what we have to do. So guys, India got gold recently in Olympics. I hope you're following it. So one question that some journalist has to ask the guy who has brought gold for us, Neeraj Chopra, we are proud of him. And somebody can ask him how many throws you make every day. So I would love to have his views on that. So he will say a number. Maybe I don't know how many throws he has made to actually go for the gold throw. Huh? So that's what you have to do. You have to practice number of times to master something. Okay. So that's what I want to tell you. So you have to bring in, drag, drop, and do again and again the same thing which we have done. So that's what is required. That you have to practice. You have to do it again and again and again so that you can master it. Right. So let's bring in Arduino. Let's bring in breadboard. So our application, guys, is a motion sensor. So for motion sensor, you have seen it's a good example to give, but in hotels, maybe if you go, you see the doors opening automatically when they detect your presence. So if you are there in the vicinity of the door automatically opens, and you have seen these automatic doors, motion based, sensor based. And maybe in the tap water also, there are sensors. So once you put your hand below the tap, the water comes out, and you wash your hands, and you take your hand away, the water supply stops. So again, a automated system over there. So motion sensor has a lot of applications, and today we see a lot of case studies, a lot of practical applications where motion sensor is deployed, and we are making use of motion sensor for various applications, automation applications. And this is something which is a breakthrough. Why? Because we are using the technology, right? We are using it in a product form, and already it is doing a good job. So let us see how we can design a simple motion sensor based application by making use of Arduino. So what I'm going to do is I will take a PIR sensor. So this is a passive infrared sensor, guys. It's also called as a motion sensor. So let's take it out and hook it like this. Okay. So this is a motion sensor. This is the active part for the motion sensor. So you can see this is a signal, and I'm going to connect it to pin number 2. Like this one. Let's take it to blue color. Okay, this is the power pin. Let's connect it to the supply, and the supply in this case is this one, and we are going to take red color for this. Next, what I need to do, I need to connect this ground to ground pin, and the ground is here, like this, and we can change the color to black. Perfect. So we have connected a PIR sensor, but we need to provide ground. So ground has to be taken from Arduino. So we can take it from here, and we can connect it to minus, which is here. Let's read out the wires the way we want, like this. And then what we need to do, we need to take supply, which is available over here on 5 volts. Let's take it, drag it, take it up, and connect it here, like this. And this is to be denoted by a red color. Perfect. So the circuitry is ready. It's perfectly fine. We have connected our output on pin number 2. Signal is taken over here, and it is connected to pin number 2. And then we have got our power connections ready, the VCC and the ground pin connection. So everything is looking good as of now. So what I want you to do, whenever the motion is detected by this particular sensor, in that case, what I want to turn on the onboard LED, which is connected to pin number 13. Okay, so this is our target, that we want the onboard LED to be turned on whenever the motion sensor is going to detect the motion of any object in the vicinity. Okay, so what we can do, guys, over here, we can go back to the coding environment, and now you have to choose whether you want to use block based approach or a coding based approach. So here I need your help. What I should do? Shall I show you from block based approach, or shall I show it from coding based approach, or shall I show you both? So that's where I want your suggestion. If you want to give me suggestions, then I am ready to take them on. I don't know what is happening in the chat box, so let me take text-based approach initially.
So
So
they
let's
say
delete the
both.
code. They're saying both. Okay, so
Yeah.
let's do it in both the ways. Okay, so I'm gonna show you in both the ways, guys. Don't worry about that. So let's do it coding way first, the hard way. So I told you there are two functions that you need to declare. One is setup, void setup, and the other one is void loop. So the loop function that you need to declare over here, bang on, like this. So guys, one thing which I want to ask you, in this case the output is taken from this pin, signal pin, and it is provided to Arduino on pin number 2. So the output of this particular sensor is actually getting fed on pin number 2. The output of this particular sensor is actually getting fed on pin number 2. So for this sensor, this pin is actually the output pin, but for Arduino, since it is actually reading the output of this particular sensor, pin number 2 is supposed to be configured as the input pin. So guys, you have to configure pin number 2 as input in this particular application. Why? Because it is reading the data from the sensor. So since it is reading the data from the sensor, we're gonna declare pin number 2 as the input port pin. So what I will write over here, pin mode, and we'll write 2 comma input. So pin number 2 is configured as input. Perfectly fine. Now I told you what I want. I want you to turn on the LED which is connected to pin number 13, the onboard LED, in case motion sensor detects something. So what I will do, I'll configure pin number 13 as output. Pin 13 is supposed to be configured as output. It is case sensitive, so you have to be very careful with the case. Here you have to write the logic, guys. Before you write the logic, before you actually write the logic, what I would recommend you is that don't do anything. Just run this code. This code is doing nothing. We're just trying what is happening. So you can see when I click on this, I can see an object. This is actually an object. So whenever the motion is going to be simulated, this has to be simulated by moving this object. Okay, this is number one that you need to see. Number two, guys, you have to know what voltage is getting generated on pin number 2. For that, I will make use of a multimeter. So let's bring in a multimeter. This is a very important gadget. It is going to tell me what is getting generated on pin number 2. So what I will do, guys, I will connect it to one of the pins. So what I can do over here is I can just escape. Delete this wire. Connect this wire over here. Or rather, do a proper routing so that all of you can actually understand it properly. So let me route it properly for you. So I'm just connecting it over here. A bit of rerouting I'm doing, guys, so that I can easily connect multimeter. So this is to be represented with a blue color. This is good. Okay. Looks fine to me right now. I'll connect this positive wire on this point. Okay. So multimeter is going to take what is getting generated from the sensor, what is getting outputted by the sensor on this line. This is same. Any of these holes are same. Okay, whether I connected here, it's same. It's shorted internally. And we're going to take output from this pin and we'll feed it on pin number 2. So let's feed it on pin number 2 like this. This is perfect. And now this one is ground. So what we can do, we can just connect this one on ground, which is here, and change the color from blue to black. That's it. So if I run the simulation now, see what is happening. This is 0. The voltage on pin number 2 is 0. Now if I click here and if I move this object, see it becomes 5 volt and then it comes back to 0. Just put your attention on the multimeter, what is happening. If I move this object, it becomes high and then it becomes low. If I move this object, it becomes high and then it becomes low. By default, it is low, and when I move the object, it becomes high. So I have to check actually when it becomes high. And if it becomes high, it means there is a motion. And if it is stationary, then it means the output is 0. So I have to play with this logic. That's it, nothing else. So what I can do, guys, I can go to the coding environment and I can change the code. In the code, what I can write a simple statement over here that so what is happening over here, I have to stop the simulation and then go back here and write if digital read. So you have another command with you to read the state of any pin. If you read the status of pin number 2 and it is high, it means that there is an object. So I can put a comment, there is moving object. And what you can do, you can turn on the LED, digital write 13 comma high. Perfect. If it is not high, then it will be low. So you write else. Else, in the else block, what we can write, stationary object. So this is a comment, stationary object. You will write digital write 13 comma low. You will make sure that it remains in the off state. Okay, so this is a simple logic that you have designed. Let's give it a shot, whether it works or not. So start simulation. And on this side, focus your attention on the object and on the state of LED. I want you to focus on this area L. This is the onboard LED. So if I move this object, so you can see LED is turned on and then it turns off again. So you can see when I move it, it turns on the LED. If I move it, it turns on the LED. So LED is getting turned on whenever there is a motion, and whenever the object becomes stationary, then in that case LED is turned off. So you can see this is happening very well. So whatever your code is, it's functioning perfectly fine. So whenever you are moving your object is moving, LED is in the on state. When it becomes stationary, LED goes to the off state. And when it moves out of the range, in that case, nothing is going to happen. Why? Because the sensor is not able to detect it. Sensor's range is within this segment only. So it has to be in the segment of the sensor like this. So once it is there, it turns on and then it turns off again once it is stationary. Is it clear, guys? So that's how you can design a simple motion sensor based application on Arduino, where we have used Tinkercad for simulation. We have used a PIR motion sensor, passive infrared sensor, and then we have written a simple program for actually reading the sensor data and performing some action. That is to control the LED on the basis of the state of the sensor output. One more thing to remember over here, guys, that you can do the coding like this, or you can actually go for block-based approach, which you wanted to do with me. So here what I can say, you can actually make use of this block-based approach and use the blocks like control, because it has this if else block. You can make use of something like this to design this application. Okay. So would you like me to try this out, or you want you to try on your own? Because that's where you improve. If you want to try, you can try, and in case it works, perfectly fine. In case it does not work, you can write us back and we will give you the solution. What do you say? You want to try this, or shall I do it and tell you how to do it? I think let's give it a challenge to you. Give it a shot, and in case it works for you, it's great. A hint can be given from my side that from control block you have to make use of this if else. One of the statement will become the part of one of the statement, which is, let me just put it in dustbin. Okay, so
So they want to try on
here,
their own.
yeah, they can do it. Why? Because they are all intelligent people over here, so they can just take any pin. So built-in LED to be made high, and then built-in LED to be made low, like this, and then you have to put in a condition over here, and the condition is something which you have to read. Read the state of a distal pin like this. Read the pin for which pin you want to read. Pin number 2. Read distal pin 2, and then some sort of a mathematical operation you have to perform, or maybe something else, right? So you have to check whether it is high or low. So here you can see different blocks are available with you, so you can see which one can work for this application and choose. Okay. Okay. So will you give it a shot? Will you give it a shot? Yes. So give it a shot and see what can be put into this block. Okay. And we would like to see your solutions, and you can try your logic, and in case it works fine, it will be great. If it does not work fine, we'll give you the solution. Okay. But a hint is given from my side. This is how it should be. You have to just apply your mind and put one statement over here. Right? Perfect. So this is application number 2, guys, that you have designed. Congratulations. This is what we wanted. Let's move on to the third one. In case you have any questions, I'm open to taking them up. Ramika, let's take a few questions if they have any. before we move on to the third one, that is the light
As of
sensor.
now, there are no questions.
Great.
Yeah.
So let's take Arduino again. Take one breadboard. Take the sensor, right? So what we can do, we can make use of another resistance, and you can actually connect it like this. This is a 10 kilo ohm resistance that I will be using for this application, and I'm gonna rotate it like this. This is where it needs to be connected. One end of the resistance you have to connect it to supply like this. You can change the color to red. This end has to be connected to the ground pin. You can connect it like this and change it to black. The output has to be taken from this pin, and this will be an analog signal. So here we will learn how to process the analog signals. So we will take it and we'll feed it to one of the analog pins, which is A0. So you can feed it to A0 like this. Okay, perfectly fine. So far, so good. Looking fine. Just change the color to blue. What you need to do, you need to take ground and connect this ground from here to the ground pin, which is this one. Connect it like this. Shift it, and let's have a black color for this one. This way. Okay. What we want is a supply voltage, 5 volt, which is here. Take it from this pin, take it up, and push it here. Great. Let's change the color to red. So far, so good. Circuit is fine. We're gonna make use of this onboard LED again. So now, once we start running the simulation without writing any code and click over here to change the light intensity, this is what is happening, guys. You can change the light intensity with this slider. Okay, this is a slider. What we can do, we can again make use of multimeter. Why? Because it's a handy gadget. And just change the position of this one place up. Output is taken from this point, so I'm going to take this pen and I'm going to feed it to positive and change the color from red to blue like this. This is the ground pin, negative pin. We have to connect it to negative, so we are going to take it to negative pin, which is here. Right. So before we make the logic for this application, guys, what I want you to understand is how to think. How to think. That's a big question. How to think. So you have to run the simulation without writing any code and just see what is happening. So here you can see that the multimeter is saying that the output is 5 volt. But if I change the light intensity, you can see that the output is actually changing. So once I take it towards light, the output is 241 millivolts, which is quite less, 0.241 volts. And when it is going towards darkness, the voltage is increasing. So LDR is a sensor, guys. That's called light dependent resistor. It is actually a resistance, not a sensor, but we have actually made a sensor out of a resistance. Here, the catch point is that the resistance of LDR is going to change with the change in the light intensity. So if the light intensity is more, the resistance of this LDR will be less. Okay, the resistance will be less. In case the light intensity is bad, the light is not there, the resistance will be more. So it's a inversely proportional thing. You can say negative resistance. So you can call it as inversely proportional thing. So you can say that if the light intensity is more, resistance will be less. If light intensity is less, is less, the resistance will be more. So Ohm's law, something which is taught to you in 8th class, I is equal to V by R, and teachers hate when they hear V is equal to IR. Why? Because they say I is equal to V by R. Okay, so the current flowing is something which is I, and it is V by R. Okay, I is directly proportional to V. The current flowing is proportional to the voltage difference. Okay, V. So it is not V proportional to I, it is I that is proportional to V. So I is equal to V by R and V is equal to IR. That's how it is derived. Fine. Ohm's law, basic Ohm's law. So if resistance is more, then I into R will be more, obviously. So voltage will be more. So when the resistance is going to be more, the voltage is going to be higher. Okay, because we are taking the output from this particular point with respect to ground. So it is the output across this particular LDR that we are trying to analyze. So if it is on the low light condition side, the voltage is high, 4.74 volt. If it is going towards the light side, the light is getting more and more. The resistance is decreasing. The resistance is decreasing, and that's the reason why the voltage I into R is decreasing. So the voltage will be less in case the light intensity is more, and the voltage will be higher in case the light intensity is low and resistance will be higher. So I hope you are getting the point. So let's put it again in a simpler way. Light intensity higher, resistance will be low, voltage will be low. If it is dark, light intensity is less, resistance will be more, voltage will be more. So here in this case, what we have done, guys, we have actually connected our circuitry in such a way that we have the output which is getting generated from this LDR that is being fed to analog channel A0. So we can read this analog channel A0. So we'll go to code and we'll take again text-based approach. We'll delete whatever comes and then design our own function. Void setup. And then you have got void loop. So in the setup function, what I'm gonna do, I'll declare 13th pin as output pin because I'm gonna make use of pin number 13. So I'll write pin mode 13 comma output, and here what I will do, I'll make use of a variable called temp, and I will write a command called analog read, and I will read the channel A0. I'll read the channel A0. So temp is a variable that you need to define, and you have to declare it as integer type variable int temp. So guys, this is what we have done. One thing which we'll use is a serial communication. So we'll write some serial communication commands. Serial dot begin 9600. So this is for initializing the serial communication at a baud rate of 9600 bits per second. And later what we can do, we can write the data on serial port, serial dot println, and we can write temp. So it is going to give us the value of temp variable on serial port, which we can read. So guys, this is what we have done so far. We have configured pin number 13 as output. No need to configure A0 as input because analog pins by default they are configured as input. So I haven't done that. I am just reading the data which is getting outputted from the sensor and is being applied on pin A0, and I'm going to perform analog to digital conversion on this particular line number 10 with a command called as analog read, and this is going to convert analog data into its equivalent integer value, and the data will be stored in a variable called temp that we have declared right at the top on line number 1 of type integer. And then what we are writing serial.println temp just to print the data on serial port so that we can read what is getting generated by the sensor in integer equivalent form. So what I'll do, I'll just give it a shot and try this code. Nothing is different, just serial monitor you have to open. So you can see it's showing 969. If I click on this and I take it on the darkness side, so this is on the lighter side. So on the right you have sun, on the left you have moon. So you can see if I take it towards sun, the resistance decreases, the voltage decreases, and the integer equivalent value is also coming down. If I take it on the moon side, on the left hand side, then in that case, you can see that it is increasing, 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 darkness increasing, voltage increasing, darkness increasing, integer equivalent value increasing. So guys, you can see that now in this case, it's getting beyond 150, 150, 180, 200, and so on. And it may become 268 at some point of time. And going further, it may increase, it may increase, it may increase, and become 969. So we can give some sort of a threshold over here, like if the darkness level is, let's say, 169 or 182, below this, we will turn on the LED. Okay. So what we can do, we can stop the simulation and we can write a simple logic over here. If temp value is greater than 182, if temp is greater than 182, which means the integer equivalent value of the output of the sensor is more than 182, then turn on the LED. Turn on the LED, it's dark. So how can you do that? You can write digital write, and within the bracket you can write 13 comma high, right? And else you can write another comment, turn off the LED, it's bright. You can just write a command like digital write 13 comma low. So that's what I have written over here, 13 high, 13 low, and we have given a threshold over here, 182. You can start simulation again, clear this, and see LED is on right now. So we can just turn it off like this. So right hand side towards sun, it's off. Let's make it dark, 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 dark. So you can just keep a watch on LED, which is this one, and this value. The time it crosses 182, it's going to turn on the LED. You can see now it is turned on. This LED is turned on. So night lamp is functioning fine, guys. It's night lamp which is programmed. So you can see it's working perfectly fine. So this is a classical example that you can take it as a reference for making something called as a night lamp, or you can say street lights, which open automatically on the basis of light intensity. So you just need to do one calibration, and once you do that calibration, you can actually make use of a simple circuitry that you design by making use of Arduino, and instead of LED, we can make use of a relay also to control a AC lamp, which is running on 220 volts. So that is again a possibility, guys. But the logic is this one, that you have a sensor which is designed by making use of a light dependent resistor, and you have a logic that you have made with the help of Arduino. A program has been written on Arduino to actually read the data of the sensor and calibrate it and actually do a thresholding so that you can write a simple program to turn on the LED or a lamp whenever the light intensity it falls below a threshold value. So this is how the night lamps are designed by making use of Arduino. And a quick simulation of that is what we have done right now on Autodesk Tinkercad. And this is what you have seen live right now on this platform, that how you can easily write an application on Arduino for reading the analog sensor output and processing it in Arduino environment, and actually doing it on Tinkercad, simulating it first, and now you are good to go ahead and do the final routing of the wires on hardware and test your circuitry in real time. So simulation plays a very important role because it allows you to calibrate your circuitry. It allows you to test your logics on the platform rather than testing it on the hardware. You're not burning anything, it's free, and it is something which is the need of the hour. Why? Because straight away you will not go and commit a mistake on the hardware. You first design it on simulation. If it functions fine on simulation, you proceed ahead and do it on hardware. So that's what we have done right now, that we have designed it on Tinkercad, and it's working perfectly fine, guys. Congratulations for making another circuitry on Tinkercad using Arduino, and this is your night lamp that I want to do it for you. So now, if you have any questions, we can proceed ahead and take your questions, and if not, we'll proceed ahead with the last exercise that I have kept for you, that is designing a mobile phone application using MIT App Inventor, that is for speech recognition, recognizing your speech and converting it into a text. This is what we are going to do next. But before we do that, I would request you to ask your questions in the chat box. And Amika, please help with the questions so that we can take them up before proceeding further with the next exercise, the last one for the day, that is designing an Android application for speech recognition on MIT App Inventor.
Lot of questions for sure. I'll just start with the one. Why did you declare variable temp of integer type when analog pins can have any value? What will happen
Ah,
if voltage comes out of the float?
so the first part is clear to me. Why did I declare it as int? The second question is something which you have to repeat again.
So what will happen if voltage comes out in float?
Okay, so voltage will always be float, guys. Do not take it like it is going to be an integer value. So this is just for the convenience that I have taken it as an integer so that you can actually read it properly. Otherwise, you can just keep it float and you can just keep again going to work for you. Let's just run the simulation again and see what happens. So you can see now you have this one. Okay, right? So you have decimal values now. You can declare either a float or a integer. It's up to you, perfectly up to you. There's no issues at all, right? So just need to declare a variable of any type you want. Could be an integer, could be a float. Yes, when you write it integer rather than float, you lose on the accuracy part after decimal point, but that's perfectly fine for application where you are doing just thresholding rather than measuring the actual light intensity in lumens, right? So this is something which is going to work for this case scenario. Okay.
So the next question is, what is a prototype platform mean? What does prototype platform mean?
Okay. So prototyping is something which is the baby step towards production, right? So once you produce any product, the first thing is you do prototyping. So you test everything, whether it is a feasible idea or not, right? In Hindi, you say namuna. That's how we say. "Ek uska namuna banana." So that's what we say that you make a prototype of that, model of that, something which can establish the proof of concept that it is workable idea. It is something which we can think about, which we can use for production stage, which we can scale up and take it to the production stage. So this is what prototyping means. And platform is something which is a bigger word, a bigger thing. So it is a prototyping platform. That's what I told you when I started off with the introduction to Arduino. So it's a prototyping platform, which means it's a proper platform which has both software part and hardware part. So it's something which is an ecosystem of hardware and software that is available to you. That's what I called it as platform. It's not a wooden platform. It is actually a platform of software and hardware, which allows you to create the applications or prototyping of the applications. Okay. So when I say prototyping, it is namuna in Hindi. It is a model. It is actually a baby step towards production side where you will establish the proof of concept. And when I say platform, what I mean by saying platform is not a wooden platform. What I mean by saying a platform is an ecosystem of hardware and software that is available from Arduino that allows you to build and prototype your applications quickly.
Right. Another question is, can you show hardware example? Can you show hardware example?
Okay, I can do that for you. What I need to do is in my draw, I need to find the hardware. Just allow me a moment. If I get it in my hand straight away, I will love to do it for you. Okay, just allow me a moment. Okay, I got it. This is the hardware with me. Okay. So the only thing is that how do I show it to you? Because I will try. So let me just try to feed in an example over here, guys. Let me see if it can work. Yeah. So I don't know whether this is visible to you. Is it visible now?
Yes, it is visible.
Okay. So
I'm
can you
removing
see the
this.
can you see the LED blinking?
Yes.
Okay. So this is what I have done. I have fed in a program for blinking the LED. So you can actually see this LED blinking.
Yes, we can see that.
Right. So this is one program which I have uploaded over here on the target hardware. So what I can do for you guys, I can actually change the program, and I think this is what we can do. I can change this particular program, and probably you can see the LED blinking faster. Would you like to see that? Shall I show you that part if it is required?
Please do that.
Okay.
We're
So
becoming
just
greedy
zoom in
now.
again. Sorry.
We're becoming greedy now.
Okay, it's okay, perfectly fine, no issues at all. So I will be more than happy to show it to you. Okay, so just bear with me for a moment. What I will do, I will quickly open up the hardware, the software. So on my screen right now, what I will do, I'll just open a program. You can just show the screenshot as of now. Allow me to share the screen so that they can first see the program.
Done that.
Okay, so guys, you can see the programming environment over here. This is where we write the program. So I can just quickly go and check whether I have my board with me. Yes, it is there. Board is no. This is fine. So I can write the program over here again. So I'll quickly do that for you so that we don't waste much time. In mode 13 comma output, right? And in the loop function, we can actually write digital, right? Then I can write 13 comma high. We can give a delay of 300 milliseconds, and then we can write digital, write 13 comma low, then a delay of 300 milliseconds. So this is looking good to me. So I will save this one somewhere. And now to upload this program, I just need to click on this button. So now you can stop sharing the screen and allow the access of the camera so that they can see what is happening on the board. So guys, I'm just uploading. I'm just clicking on upload button, which is on my screen. Control U is a shortcut. So I will upload this message. And before that, I need to select the board. Okay, the board has to be selected, which is Uno. Right. Yeah. So the permission is not there with me right now. So it is showing me error of this. Yeah. So allow me a moment. So guys, what I'm doing right now, I'm just hooking it up with my PC, again the cable, and uploading this program. So just wait for a moment. Generally, it takes some time to set it up. So we have to do this exercise in just 5 minutes. So here, because the setup is under process on my PC. Okay. So since we have started it out now, so we have to do it. Let me try. It's taking some time, guys. So I may need excuse from this for some time. Okay, so allow me that because this is under process. Okay, so you can see that this is under process and it is now opened up. So let me try this one. Uh, go to this one. Yeah, we have this. Go to tools, go to code. Here it is on 7. Upload this one. Right, the process is on, guys. So this board is creating trouble for me right now. So allow me some time to debug this application. Okay, so I'll take excuse for this one, and let me try with another board and another cable because this is creating some issue on the system right now. But before we end the class, I promise that we are going to do it, right? So if you have any other question, we can take it up.
Not yet.
Apologies for the hardware thing. This is creating some trouble. The board may not be a functional one, which I have in my hand right now. We'll try to see if I can arrange something quickly for you before we end today. Uh, I'm gonna show it to you. No issues. Okay, Anamika, do we have any other question?
No, not yet.
Not yet. Okay, perfectly fine. So let's try to finish it off, and let's try it this one at the end if the time permits, because this board is creating trouble right now. It's not getting read by the software. So what I will do now is that I'll get on to the app part. So for app, guys, what you need to do, you have to write MIT app inventor. So this is what you will use for app development today. So open in a new tab, and here again your Gmail account is going to help you out. So just click on create apps, and here what you need to do, you need to log in through your Gmail account, whatever you have. So I'm going to log in with one of my Google accounts. And to create the application, guys, what you need to do, you need to click on start a new project. So this will show you last application that you have developed. So you have to go to projects, click on start a new project. Here, give the name of the project like speech recognizer. Okay, click on OK. So here, guys, what you need to do, this is your mobile phone screen. And what I will tell you right now is go to media and take this particular activity speech recognizer, drag and place it here. So this is a hidden component, speech recognizer, that will be here, and take in a text box. Text box will come from user interface, and this is going to be here. Just drag and drop and place it here. Okay, this is the text box, and if you want to increase the text box size, you can do that. Okay, so we can just change the property of the text box from here. The height is, let us say, in terms of pixel, we can take it to 300 pixels. Click on OK, and maybe the width in terms of pixel, you can keep it 300. It becomes a big box. And height, if you want to reduce to 200, also you can do that. So it becomes like this. So this is a text box, a bigger one. We'll take a button. So this button will be renamed. So you go down, and here uh, speech to text converter. Okay, so speech to text converter, STT is what I have written over here. Okay, so what I can do now is I can go back to the blocks panel. In the blocks panel, what I can do, I can click on button, and I can give a block like this. When button is clicked, and call the speech recognizer and get the text. This is the block that I'm taking. When the button is clicked, call the speech recognizer and get the text. And I'll go to speech recognizer again. After getting the text, set text box one text. So you pick up this box, place it here, set text box one dot text, convert the result. So this is going to actually call the speech recognizer, which is going to convert the speech into text, this block. And then once you have the text, you can actually use the result of the text over here. So speech recognizers result this way. That's it. So this is a logic that I have designed for this app, that when the button is going to be clicked, speech recognizer is going to get activated. It is going to convert the speech into text. Once it gives the result is available in this block, and we are going to set the text box 1, which in this case is this one. This text box is going to be getting the result of the speech recognizer, which is in the text form. That's it, nothing else. So this is the application that we have developed. In order to install the application in the mobile phone, what we can do, we can click on this build button, and I can say provide QR code for this particular application. Okay. So guys, what I will recommend you now is you can download one uh, application from Play Store for scanning the QR code. The name of the application is MIT AI2 Companion. MIT AI2 Companion. So just download this application, because I would like you to actually scan this application, this QR code, and download it on your own systems. So this is what you should do. Otherwise, what I can do, I can make use of my own. I hope I am audible, because I have just minimized the screen of my system.
Yeah, you are audible.
Okay, so what I will do, I will open this application called MIT AI2 Companion. So the application name is MIT App Inventor 2, MIT AI2 Companion is the application name. So this is a QR code, guys. You can just scan this QR code to download this application. I'll click on scan QR code, and I'm scanning it in my mobile phone application. So this is what I have got. So you have to install this application. So I've installed it. So you want to install this application, allow the access of applications. So there is a setting that you need to enable in your mobile phone to turn on the access to unsecured apps, maybe. So once you install this application, you have to open it. So have you installed? Any one of you? Have you tried? Is it working?
They're still doing this. Some
Okay.
of them
So
have
what
said
do you?
yes.
Okay. One of them has said yes.
Some of them, yeah.
Some of them. Okay, that's great. So you can just scan this code, install this application, and try it out. So once you click on this button that you will be getting on the screen, it is going to enable the speech to text converter, and you will be getting the text that you can see on the text box. Okay, so try this out, guys.
They say it's working.
It's working for somebody. That's great. That's great
Yes.
news. So the QR code is there with you. So this is a mobile phone application that you see now in your mobile phone, and it didn't take much time for us to develop this application. So it was just drag and drop of certain blocks, combining it together, and job done. We have the application working. So this is a classical application that we have seen how we can convert a speech into text. So this is what we have done, and the text will be available in the text box. So for the demo part, I will encourage you to download this application from this QR code. This QR code is visible on your screen, so you can just use any QR code scanning application for testing it out. The other one that you can use is MIT AI2 Companion for the MIT App Inventor, and that will allow you to use this particular application straight away in your phone, right? Maybe for certain phones, the settings may not allow this application to be installed directly. So you have to turn on the app installation for the unsecured apps so that this application can get installed. Okay, because it's not from the Play Store, so it may give you the warning. So you have to just turn on that preference, and then once it is done, you will be able to install this application on your phone and you can use it. Okay. So I hope we are getting yes in the chat box.
Yes, we are getting yes.
That's great. So can
There's
I close
another
this one?
question. There's one question. Will
Yeah.
this application support Hindi and other languages too?
It's gonna support English as of now. Why? Because the speech converter is from Google, and
Okay.
if you use Hindi, it is going to give you WhatsApp Hindi. I hope I'm clear,
Yes.
right? So if I'm gonna speak in Hindi, it is going to give me exactly the same thing, but it will write it in English. So it's a WhatsApp Hindi or WhatsApp English, whatever you call it as. So you'll see the text in English, but it will be Hindi when you read it.
Right.
Can you try? Any one of you? So try something in Hindi, speak in front of the application, and you will see a WhatsApp version of that Hindi coming up. So it's
English
going to be
letters,
written in
yes.
yeah, it's going to be written in English, but yes, it's going to be Hindi when you will read it.
Right.
Okay,
Perfect.
so this is one application that I wanted to show you how to convert the speech into text using this platform called MIT App Inventor. It's again a very user-friendly tool, browser-based and online. You can make use of this tool for creating some fantastic application without writing any code, right? So anybody who has good logic can create some great applications on this platform, and the more you try, the more you learn on this platform, the better apps you will be able to make. So a lot of features are available, like a lot of sensors are there, a lot of built-in blocks are available that you can make use of, and you just need a brilliant idea, and then you can develop the applications around this platform. A lot of people around the world are using this platform for creating the code-free applications, and you can create the apps and you can start using it right away. So this is one platform that you should explore in the near future and try your best to make use of the apps that you develop on your own. Okay. That's it from my side. It's 4:57. We are supposed to wrap up in 3 minutes. Any more questions?
I don't see more questions. They are excited about the app, I guess. So if
That's
no more
great.
questions, I don't see any
Can,
questions
that's great. So
now.
can I take the floor for 2 minutes for sharing
Yes.
about the Udemy course if it is allowed?
Sure, please.
Okay, thanks a lot. So guys, on your screen, I can show you one more stuff that we have done on Udemy. So here, there's a course from my side that I have recorded for this one. So this is the one, hands-on Arduino, right? So this is the one. So it has 9 hours of video content. So you can try and see this course if it is of your requirements. So this is again a complete course that I have designed right from scratch. And there are various topics that are available from Bluetooth to servo motor to DC motor. And it's completely a video based course, which means that whatever we do it live the way we do it. So you can see myself on the screen explaining the concept on Tinkercad. So it's a course on Tinkercad and Arduino both. So again, step-by-step approach is what we have followed over here. This is something which is very costly right now on Udemy. I can open a new window just to show you how it is and what is the price for this one. This is very heavy in terms of costing. Won't encourage you to purchase it right away at this heavy costing. So what we can do, we can share later on the coupon codes with you so that you get it at a subsidized rate so that you can learn without paying too much. Right now it is priced at 8,640 rupees right now, which is something which is very heavy. I don't recommend you to purchase this one at this price. So you will be getting it at 360 rupees only later on in case you want. The coupon codes will be shared by the organizers in case they allow it and in case they want it, right? So this is one effort from my side that I have put in for 9 hours. And in case it is worthy to be used, you can try it out. Okay. So that's it from my side. Thanks a lot.
Thank you very much, Dr. Umesh. It was indeed a lovely, lovely, 2 days interaction that we had. Uh, I would now like to request. First, I have to invite him. Sorry. Um, yeah. So I would now request Mr. Rupesh Singh, Associate Vice President, Ananda Bharati Publishers, to say a word of thanks.
Wow, what a learning! What a learning! Even in fact, I was also trying, along with this participants over here. So something different. I also got an opportunity to work upon. So hello everyone. I would like to begin with a special thanks to Dr. Umesh, who spared his 2 precious days to introduce to you the concept of artificial intelligence. And his energy and enthusiasm has encouraged even us to try out the techniques that he has taught. In fact, I'll be trying this in the evening, late in the evening. I'll also try something out. Thank you, Dr. Umesh. And all this knowledge will be no doubt very useful for all of us as we go forward in our life. I would like to extend my special thanks to the teachers, to the schools, to all the participants over here, and we look forward, having you again on board with a series of new events, with more and more of new learnings, new ideas, new concepts that we can bring in for you, and you learn a lot and keep learning. We'll be always around to help you in this process. Okay. Thank you so much.
Thank you very much, Rupesh. And once again, I would like to thank Dr. Datta for taking out time for the 2 days. It was a wonderful session, and I was working alongside today for a change. I'm a tech challenge person, but yes, I did try to follow your instructions and do things. Thank you very much. Thank you to all the students who have participated. I saw the number of views we have had on our yesterday's session. It's amazing. It's very encouraging for all of us, and I promise, we are going to bring you more such sessions in time to come. Thank you once again. Have a great evening, all of you. Stay safe. Stay at home. Thank you.
Thank you. Thank you. Stay blessed. Bye bye.
Yeah.